Jeeps, but the topic, or not the topic, but the binary I'm going to focus on today is from a war game site called Hack.lu. And I'm using this one because it is an automated exploitation challenge. So for those of you who aren't familiar, it's a Korean website, which is a war game website, so it gives you binaries that you have to exploit. And we're going to take one of those binaries from the site and write two tools that will automatically exploit it. Will give us the shell automatically, give us the play. Because we're pretty lazy and tired of information. Alright, so the binary that I chose from the site has a few properties. The target that we're looking at today. First of all, you only have 10 seconds to get a shell box. We know that it takes our input and our using one. It does some operations on it, which are starting, so which happen every time. It then calls a random sequence of 16 functions and 3 checks in each function. And those change every time we connect to the server. And so we don't have any way to hard code those checks into our tool. We know that each of these 48 checks will change every time. So the numbers will change, the operations will change. There's no other way that we can statically hard code those. We have to have a tool that automatically can learn what these checks are. And we know that if we get past all these checks, we will get down the right path in the CFG to our vulnerability. And we know how to define our corruption using those read and write parameters. Now, using automated exploitation, we want to generate that input, which will automatically find and get us to the vulnerability, as well as generate a payload automatically to exploit this vulnerability and get us the shell. So we'll exploit the spam copier, the right corruption bug, and get us the shell out of the box. Now, an example function from this binary is right here. You can see that this is one of the 16 functions, and this function has 3 checks. And you can't see what the checks are, but we don't need to because our tool is going to do that for us. And it's going to pull out the operations as well as the values. This is just a diagram of what this binary is. So this is the target that we're looking at today. And you can see that we want to get down. So how can we actually use automated exploitation to solve for this? How can we actually create a tool that automatically exploits it? We know what we want to do, it sounds great, but how do we actually do this? And the answer to that is software program analysis. So using program analysis techniques allows us to automatically encode the definition of our vulnerability and exploit this program automatically. And that's going to be the third part of my talk. So what is program analysis? It's the process of automatically analyzing applications, which sounds great. That's what we want for automatic exploitation. Now, traditionally, program analysis in the past 30 years or so has been developed a lot for compilability research. So you're analyzing this program, the compiler is, in terms of 2 different properties. Correctness, which is basically asking the question, is the entire set of paths in the CFG, is the entire set of paths that are possible for this program the expected set? So is there any extraneous, or is there, is the set too small or large, basically? Is there more paths than there should be? Is there unexpected execution behavior of the program? Or is everything good? Is everything sound? So what we really want to say here is, can we find program incorrectness? Can we find a place in the binary where we can cause it to go down a different path or create a different execution pattern that's outside of the intended set of possible paths in the CFG? Now, optimization for compiler theories is pretty important, but we don't care about this one so much. It's basically saying, are all the instructions there necessary? Is there any way to optimize it? But for program analysis, we know that we want to focus on the first, so program correctness. And in lot of subtheories. So there's a bunch that you go into model checking and different more abstract concepts. But the three more concrete areas of program analysis are instrumentation, symbolic, and concurrent execution. And we can use those to create automatically, we can use those to create tools which will automatically exploit the program for us. And now, I mentioned at the bottom, but a lot of times you see that people combine these different techniques in program analysis to create a more optimized program analysis tool, which quickly or more efficiently finds bugs in programs. So what do we care about? Instrumentation. Instrumentation is pretty great. Most people are familiar with this one out of all